So this is our first end of year review. Today we'll be working on factoring with quadratics and imaginary and complex numbers. For number one, it says for the function y equals x squared minus 2x minus 15, over which of the following intervals is f of x greater than 0? So that's a y is greater than 0. So if you're graphing something, it's all of the points above the x-axis. They all have points where the y is greater than 0. So what I did was I went to Desmos and I typed x squared minus 2x minus 15 in the calculator. And if you look, get a different color, all of this section here is greater than 0, and all of this section is also above the x-axis. So basically, if I take this point as my ending point, the x-axis, this goes from negative infinity to negative 3. Negative 3 is not included because then it would be equal to 0. And then from here, our graph goes from 5 to positive infinity. So I'm just going to rewrite that on my packet. So this goes from negative infinity to negative 3 and 5 to infinity. Now, I wrote that in interval notation, but our answer is written in set builder notation with the inequality or the alligator mouth. For number 2, the function equals y equals negative 1/2 times the quantity x minus 6 squared plus 17 is decreasing over which of the following intervals? So I'm going to come back here, Magic of Desmos, and I'm going to type that in. Now they want to know where it is decreasing. So here's our maximum and it's decreasing here. So we're going from 6. Now this points down to negative infinity, but when we're talking about intervals where something's increasing or decreasing, we're looking at the x values. So in this case, the x value can go on forever in the positive direction. So any place where x is greater than 6. So it would be that. Number 3 is factoring. The polynomial 2x squared minus 4ax plus 3bx minus 6ab can be written as, so you can see all of our answers have parentheses in it, they've been factored. This polynomial has 4 terms, so I'm going to group them. And I'm going to take the GCF out of each group. So my first group can be factored as x minus 2a. And my other GCF is a plus 3b. And we have x minus 2. These two sets of parentheses match, so that's a factor. And then 2x plus 3b, the two GCFs, is the other factor. So you have that. Number 4, the equation, that thing right there, has a solution set of, this is already factored for us. So when you solve by factoring, you just take each factor and set it equal to 0. I'm running out of room. So I solve my first one, I just divide by 5, and I get 0. For the second one, first thing I'm going to do is square root my problem to get rid of this square. So I have x minus 7. Technically you have plus or minus 0, but 0 is 0. Add 7 to both sides, and you get x equals 7. And then the last one, I'm going to subtract 2 from both sides. I get 3x equals negative 2 divided by 3. So x equals negative 2/3. So my answer is number 3. This one you could graph on Desmos and look and see where it crosses the x-axis. That's where the zeros are. But the problem is, I'll make that one go away. The graph is a little bit yucky. So there's a couple zeros here. It's hard to tell what they are, and we know because it's a negative 2/3. And then you have that other one, which is 7. Now getting down here, we're getting towards imaginary numbers territory. If you take the square root of negative 98, you're going to get an error. So when I simplify this, I'm going to bring down my negative. I'm going to split this into 3 pieces. I have the negative 1, and 98 is the square root of 49 times square root of 2. So square root of 49 becomes 7. Square root of 2, you can't simplify. It's an irrational number. So I'm just going to leave that. Square root of negative 1 becomes I. And then I'm going to bring down this. So just to kind of rewrite this in a more coherent way, I have negative 7I times radical 2, which is option number 1.